Alright, so we're now going to move on to talk about something called the flight path equations. So the solution of the conservation of linear momentum equations and angular momentum equations tells us how the aircraft moves with respect to the body axis system, which has origin at the center of gravity. So you can think of that kind of like how the aircraft moves from a pilot's perspective. And then what we do is we use the Euler angles to relate the orientation of our body axis system to the Earth axis system. So what we would like to do now is work out how the aircraft moves with respect to the Earth axis system. So what is the aircraft's trajectory through the air? So because we have this new axis system, the x1, y1, z1, and we know that that's parallel, or we define it so that it's parallel to the Earth axis system, x dash, y dash, z dash, then we can just express the velocities with respect to this new axis system with the subscript 1s as the change in location in each of those axes with respect to time. So the velocities are just the differential of the positions with respect to time, and because they're parallel, the axis system with the subscript 1s and the Earth axis system are parallel, then their velocities in those axes are equivalent. So then what we can do using that information is apply our Euler angle sequence. Remember, we have to follow the sequence in the right order using these matrix transformations. So again, remember linear algebra. We take the velocities in the x1, y1, z1 axes, apply this matrix, which applies your angle psi to find our new velocities. Then we apply our pitch angle theta. Then we apply our roll angle phi. So what we can do is apply each of those transformation matrices in sequence, 1, 2, and 3, that's what I've described them as here, to find the velocities in the x1, y1, z1 axes from velocities in the x, y, and z axes respectively. So in order to find the flight path equations, we basically just have to multiply these three matrix transformations out to get this lovely looking thing right here. So what this allows us to do is take the Euler angles, which we find from the solution to the kinematic equations, which we're going to deal with in a moment, and also input the linear velocities, uv and w, which we found from the solution to the conservation of linear momentum equations, conservation of angular momentum equations, plug those into our flight path equations, and what we get out is a 3D trajectory of the aircraft as it flies through the air. And that can be further reduced into a 2D solution to find the ground track of the aircraft. So that's the flight path equations. We'll now move on to look at these kinematic equations and how we find our Euler angles psi, theta, and phi.